Today let's talk about time and space complexity. So when you say time and space complexity of an algorithm, right, as the name implies, it basically tells the amount of time required to process a particular algorithm and the amount of space it takes to process that particular algorithm. And it's all relative to the input size. Now suppose we have a series of numbers. Let's say 1, 2, 3, 4, 5, 6, 7. Okay. And now our task is to find the sum of all these 7 numbers. Okay. Now a simple algorithm which you all might be able to write is for int I is equal to 0, I is less than 7, I plus plus. And let's say all this is present in an array. Okay. Now what will you do? You will give sum is equal to sum plus ARR of I. So what is this essentially telling? It's telling that we're iterating through all the elements of this array, right? And while we're iterating through every element, we're calculating the sum. So initially sum is going to be equal to 0. Okay, now once it enters this loop, now sum is going to become sum, which is 0, plus AR of I. So now sum is 1. Now again it will go through the next iteration. Now sum will become 1 plus 2, which is going to be equal to 3. So what is the time complexity? How much time are you taking to run this particular code? It is basically you're going to here. So amount of time you take is basically how much time you're taking to iterate through the elements. So the time complexity here is O of 7 because there are 7 elements. Now suppose you have to calculate the sum of n elements. In such a case, then what is the time complexity? It will be O of n, right? So here the time complexity is basically the amount of time taken to iterate through all these numbers. And what is the space complexity in this particular code? The space complexity will be what are you storing? So one thing is that all these elements you are going to store in an array. So once you're storing all this into an array, the space complexity of storing all these elements will be O of n, right? Because every element here you have to store in an array. But suppose an array is already given to you. Then what is the extra space you're taking to calculate this? You're just needing a single variable sum, right? And this sum is, you're always adding values to this particular sum. So the space complexity in this case is O of 1. And this is actually the best space complexity ever possible. And even time complexity, the best time complexity ever possible is O of 1. Okay. So I hope everyone got an idea of what time complexity and space complexity actually are. And always remember that it's always going to be with respect to the input size. Here the input size is n. Okay. Now suppose you have to iterate through, let's say we have an array of O of n and you're going to iterate through the array twice. In order to get you're basically iterating through everything twice. So if you're iterating it through it twice, you're going to iterate to it n times plus n times, right? O of 2n. Always remember when you tell the time complexity to anyone, you can always ignore constants. Whenever you calculate the complexities, right, you can ignore constants. So suppose even if you need to store an array of O of n and you need to store another array of O of n, the total storage is going to be O of 2n, right? But it's you can ignore constants and say that the total space complexity of O of n. So one key point is to ignore constants. Okay. And now suppose you have two arrays. One array is of size m and another array is of size n. And now you are required to append the arrays. In such a case, you have to traverse through all these elements and also you have to traverse through all these elements, right? So please tell me the time complexity. It's going to be of O of m plus n. And suppose you have to find the sum of this array plus this array. Then guess the space complexity. already have these two arrays, and you just need a constant variable to calculate the space, right? So the space complexity in this case will be O of 1. Now suppose you have to append both these elements, and you are appending these elements into a new array. Now you have array 3. Now the size of array 3 will be m plus n, right? So in that case, the space complexity will be O of m plus n. I hope this is clear. Okay. Now there are other cases as well. Suppose you have to, let me just say, take a small example. For I is equal to 0, I is less than n, I plus plus. Okay. Now we have another for loop. For j is equal to, say is going to be equal to I. J is less than n, j plus plus. And here we're just going to do sum is equal to, or let's say answer is equal to a of I into a of j. In such an algorithm, what is the time complexity and what is the space complexity? Okay, so please take some time to think about it yourself, and once you're done, you can get back to the video. So now suppose you're calculating the time complexity. For every iteration, right? Here you're going to come. Now suppose I is equal to 0. Now you have to start, and suppose for our sake, let's consider n is equal to 3 for now. J is going to be equal to I, which is 0. Okay, now you're going to calculate answer. Okay, and now again you have to iterate through this again. J is equal to 1, and then again you're going to come in here and do j is equal to 2, and now it will come to j is equal to 3, but you see it doesn't satisfy this condition, so I'll exit this loop and go back to this loop when I is going to be equal to 1. Then again j is going to be equal to I, which is 1. Then j will be equal to 2. Okay, and then again j will be equal to 3. It won't satisfy this. I'll come out of the loop. Now I is going to be equal to 2. J is going to be equal to 2. You can see for every iteration of I, you're going through all the elements. You're going through how many elements of j you're going through from the ith element to the nth element, right? So you can see you're going through n minus I elements, just for simplicity. But it'll actually be n minus I minus 1, right? 3 minus, the first element, which is 0 minus 1. You're going to, you're actually going to n minus I elements. Okay, so for every n, you're going to n minus I elements. So time complexity of this, if you want to write it in a very simple form, it can be, in one way it can be this, but this is wrong. You should never consider time complexity in the terms of I. So what is n minus I? The max n minus I is possibly n, right? If I is equal to 0, n minus I is going to be equal to n. So this you can consider it as n and n. So in such an algorithm, the time complexity is going to be O of n square. Okay, you can see O of n square algorithms very commonly. We'll go through multiple sorting algorithms, etc. later. And sorting algorithms are basic, simple way. The brute force way. One way to do is O of n square, but there are multiple ways of optimization where we can bring down O of n square to O of n log n, etc. And now if you consider the space complexity, you're just going to store answers. So space complexity here is 1. But I hope you guys got an idea of what time complexity and space complexity actually is. Now there are cases when the time complexity of an algorithm can be exponential, which is O of 2 to the power n or O of 3 to the power n, etc. Suppose let's take a small example. Say we have to calculate the nth number of a Fibonacci series. Fibonacci series. What are Fibonacci series? Suppose you start with 1 and you have 1 again. Fibonacci is 1 plus 1 is 2. Then 1 plus 2 is 3. Then 2 plus 3 is 5. This plus this is 8, etc. Now suppose you have to calculate the Fibonacci series, the nth term. Okay, suppose you have nth term. Okay, this nth term will be the sum of the previous two terms, right? So the nth term, the answer here will be sum of, the answer of this will be the sum of O of n minus 2 and f of n minus 1. This again will be the sum of f of n minus, it will be the sum of f of n minus 4 and f of n minus 3, right? This will be the sum of f of n minus 3 and f of n minus 2. Okay, so there are ways where we do not need to compute this again, but in the case where we do compute a value again and again, you can see that for everything you have to compute two values. So in such a case, the time complexity will be O of 2 power n. Okay, but there are definitely ways in which we can bring down the exponential power, and the whole concept of dynamic programming is kind of revolves around this concept of how to bring down the time complexity, because such a high time complex algorithms, such a high time complex code will not run, and eventually you'll get timeout exceeded in most of the interview questions, and it's very useful in real time, in real life as well. You want to write the code in an as efficient way as possible. Okay, and now so now we talked about cases when there can be a time complexity of O of 2 power n. Similarly, there can be logarithmic time complexities. Now let's just say, take one example. Suppose you want to search for an element in an array. Okay, suppose you want to search for an element 4. One way you can do is just iterate through it, get 4. But in such a case, if you iterate through the entire array, what is time complexity? It's O of n. So suppose you have, this is a sorted array. Suppose it's a sorted array, and you know that you can always pick the middle. Now suppose you have to search for the number 2. You can always, or the number 6. Okay, if you normally do it, then the time complexity to reach this particular place will be 1, 2, 3, 4, 5, 6. At the 6th time, you'll basically reach 6 and you'll return the result. But suppose you know that this is sorted. One thing you can do is find the middlemost element and then compare it with the number you have here, 6. You can see that 4 is less than 6, right? So it's always, the element you're going to be searching for is always going to be on this side if it's present. So now what you'll do, you'll only search for only within half of the elements you'll search. Again, you'll see that again you find the middle. The middle of this will be 6 and you found it. So you basically reduce the search time to half. So in such a case, instead of searching for everything, every time you're going to divide the array by 2, you're always going to search by the number of elements by 2. So this will be of logarithmic time complexity. Okay, yeah, and I think this is the basics of what time and space complexity is. But as we go forward, right, whenever we code or solve a particular problem, let's try to figure out what the time and space complexity for that algorithm is. But yeah, I think I'm done for today. Thanks everyone for tuning in. Bye bye.